Today we want to look at the domain of rational functions. A rational function is typically written in fraction format. We need to remember that rational functions cannot have a zero in the denominator, and anywhere that there's an x value that makes the denominator zero means that that value of x is not part of the domain. We typically see this in, let's say, the parent function graph of 1 over x. If we look at that, and I'm just going to draw a sketch here, then you can see that it is getting very close to the y-axis here and very close to the y-axis here, but it never actually touches it, and that is because you cannot have a denominator here of 0. So this is going to have an x value that's getting really, really close to 0 and really, really close to 0 on this side, but it's not touching it. So the domain actually is negative infinity to 0, union 0 to infinity for this one. Now, how do we take that into consideration whenever we don't just have an x in the denominator? Well, we need to think about what would make the denominator equal to 0. So we're going to set this up like this. We're going to take the denominator, in this case x minus 5, and we're going to say this does not equal 0. So we want to find out what value of x here cannot equal 0. So we're going to solve this as like a linear equation. So except for this is going to be x not equal to 5. And we want to write the interval notation for this. So I'm going to graph this just so you can see what's going on here. At 5, it's going to be a hole in the graph. But this domain does include every other number. So we can shade to the right and to the left. And you can think about this getting really, really close to this number, and you can use a parentheses there if you want, and really, really close to this number, really, and you can use a parentheses there if you want. So when I write interval notation, if I was to think about these as separate intervals, then this interval would be from negative infinity all the way to really close to 5, and that's where we're going to use the parentheses. So we're going to have negative infinity to 5, parentheses, and then when you skip over to the next interval, we need to kind of have some symbol to join these two things together. And we use the union symbol. Okay, so it's not really joining them, it's just saying this is a way for us to write two separate intervals as the same answer. Okay, so it's going to be this and also this part. So we're going to have now 5 to infinity. Okay, so this would be the standard interval notation format for any rational function. So if we had, let's say, x minus 2 here, then the thing that would change here would be this 5s would change to 2s. Okay, let's do something that's a little more complicated though. So let's say we want to find the domain of f of x equals 5 over 3x minus 1. Okay, setting it up in this format helps us see a little bit more complicated expression there, like we have in this denominator, 3x minus 1. Now, some of you may be able to figure this out in your head. That's great. But for those of us that can't, we're going to actually write this out. We're going to write the denominator, and we're going to say this cannot equal 0. And we're going to solve this. So add 1. Got 3x cannot equal 1. Divide by 3. And x cannot equal 1/3. Okay, so again, if I was to draw that number line, I would have 1/3 here in the middle. Open circle. And I'm not going to draw our parentheses this time because that's not normally on the graph unless you're using a graphing utility that uses the parentheses. It just depends. Some people use open and closed circles. Some people use brackets and parentheses. But let's see if we can remember how to write the interval notation by using this kind of format. So we have negative infinity up to 1/3. Negative infinity gets that parentheses. 1/3 is going to get that parentheses. And then again, we're skipping over. So we've got this hole in the graph there. We're going to represent that with union. And that's going to be joining these two intervals together. Okay, and then we've got 1/3 to infinity and parentheses. Okay, so that's our interval notation. That would be how you would write the domain of a rational function given the function. There might be other ways to do it graphically, but this is how we do it given a function.